Chapter 2, The Chemistry of Living Things, Screencast 2. This is the second screencast available for Chapter 2, and this is the part that actually deals with some pretty straightforward, really important chemistry. The first concept that's being addressed here are the different types of energy that exist. And remember, energy is one of those things that make up the study of chemistry. We describe energy based on potential, and that is energy that's locked up in chemical bonds of energy storage molecules. You also may have heard before that potential energy is associated with position. So the higher up you are, the greater the potential energy in that particular situation. Kinetic energy, on the other hand, is that energy that is associated in motion. So movement is taking place. It is important to be able to distinguish between these two types of energies. Now, when we introduced atoms, we introduced the concept that electrons are arranged in shells around the nucleus. So let's think about this. The further a shell is away from the nucleus, the electrons in that particular shell will have a greater potential energy than those that are closer to the nucleus. Really important concept for us to mind. Now, the other thing here is we introduced the concept of stability. The most stable configuration is when the outermost shell is full. Now, I will never ask you to memorize how many electrons a particular shell can hold. That's beyond the scope of this course. But I want you to understand the fact or the concept that stability is associated with full electron shells. And atoms want a full outer shell. And so what atoms will do is interact with other atoms to fill their outermost shells, and this interaction is a bond. Now, bonding is one of the most important concepts that is going to carry over to an understanding in human organisms. It may not sound really important, but let's kind of think about this. We're going to first look at covalent bonds. Covalent bonds involve the sharing of electrons. Now, based on the type of covalent bond, some substances are going to be water soluble and some substances are going to be lipid soluble. When we talk about living organisms, this is a really important concept because it is going to translate into how do things move into and out of a cell? Can they move into and out of a cell? How are they transported in an aqueous environment such as blood? So hopefully you understand that this concept of bonding is really important. So here we're talking about covalent bonds, and as noted, these bonds form when atoms share electrons. We consider them to be relatively strong bonds. Now, some common examples are hydrogen. Now, I will always make a difference when I'm talking about molecular hydrogen versus elemental hydrogen. Same thing with oxygen. Okay? The oxygen that we breathe is actually two oxygen atoms covalently bonded together. Okay? Water is another example. So I want to make sure that you are comfortable with these concepts. Okay? Now, if we look at the types of covalent bonds that exist, there's two of them. We have nonpolar covalent bonds, and what this means, electrons are shared equally. Examples of this would be hydrogen, oxygen, methane. Okay? What's important here is those molecules that exhibit nonpolar covalent bonds are lipid soluble. They do not dissolve in water. Very important concept. Whereas polar covalent bonds, these are bonds where the electrons are not shared equally. For instance, in water, the oxygen has a stronger pull on the shared electrons than does the hydrogen. So this means that one side of the water molecule has a partial negative charge, whereas the other side has a partial positive charge. Now, keep in mind, water is electrically neutral. We're talking about the sides of the molecule. So everything near oxygen, because it has more electrons hovering to it, there's a little bit of a negative charge on that oxygen atom. Whereas on the hydrogen side of things, there's a partial positive charge. But remember, as I said previously, molecules, unless indicated otherwise, are considered to be electrically neutral. So those partial charges have to cancel out. We'll come back to these polar covalent bonds because they really are important. Now, remember when I said nonpolar covalent bonds are lipid soluble? Polar is pretty much an opposite. So that means they are going to be water soluble. So important concept that when we talk about these two types of covalent bonds. Now here we're actually looking at some examples of covalent bonds. On the first column you basically see the written formula, and on the middle column what you see a structural representation, and then on the last column the structural formula. So a couple of things you want to keep in mind here. So notice the shells overlap. So that means now because they have formed a covalent bond, that outer shell is full to capacity and has reached a stable configuration. Same thing happens when we look at oxygen, and we can see the same thing happening with water. So once again, covalent bonds are those bonds that are formed when atoms share electrons. And also remember, there's two types of covalent bonds. Polar, in which there is an unequal sharing of electrons, and nonpolar, in which there is an equal sharing of electrons. So it's very important that you are comfortable with that concept. Now, another type of bonds are ionic bonds. Now, these are formed through the transfer of electrons. So one atom is going to be giving up an electron, whereas the other atom in that molecule will be accepting the electron. So that's really what we're looking at with regards to a transfer. So if I look at a positively charged ion, that forms if an atom or molecule loses an electron. Okay? If it loses it now, it's less negative, so it's positive. If I look at a negatively charged ion, that forms if an atom or molecule gains electrons. So now it's negative because guess what? It picked up an extra negatively charged particle. Now, ionic bonds are typically a force between oppositely charged ions. NaCl, or sodium chloride, is a really good example. But when we're talking about the definition, they are formed through the transfer of electrons. I want to make sure because that's what I'll be looking for on an exam. So the transfer of electrons is how ionic bonds are actually formed. Now, there's another type of bond, hydrogen bonds, that are formed between polar molecules. So this is a little different. This is not forming a molecule. This is a bond between polar molecules. Okay, so this is important. Okay. Now, the other thing that I kind of want to keep in mind, I don't like using the term bond in hydrogen bonds. Generally speaking, especially in biology, we think of hydrogen bonds as a weak attractive force. So let's kind of take a deeper dive into what these attractive forces are. So when we look at polar molecules, remember, so these are molecules that are formed through polar covalent bonds and the unequal sharing of electron. What that means, that one side of that molecule is negatively charged. Now, what if it happens to be near another polar molecule? So here we know that unlike charges attract. So the negative side of that water molecule will be attracted to the positive side of a nearby water molecule. So this forms what we call those hydrogen bonds. We generally think of them once again as weak forces between water molecules. And this results in something known as surface tension. And that's something we'll talk about later. Now here we're basically looking at different molecules, and what's going to happen here is depending upon temperature, that's going to change the overall state. So here we can basically see that dashed line. That's typically how you know that there is a hydrogen bond. Covalent bonds are indicated by a solid line between the atoms. And so we can kind of see that. And depending upon, okay, what we see here on temperature, there's going to be different distances between these bonds. Okay, so here we see ice, and I can see probably more of them together, resulting in the solid. Okay, and then here we see water vapor, in which heat has basically broken those bonds, and we see water vapor being given off. This last slide in this screencast is actually an animation that talks about different types of bonding. I definitely recommend taking some time to review this on your own.